Hello Math Method students, this is a video helping you with your work from exercise 6D on cubic equations. This is a very similar exercise to what you did in 1B on linear equations and 3C on quadratic equations. You use very similar methods such as making the equation equal to 0, factorising the equation and using the null factor law. And just a reminder of the null factor law is there, the way we used it for quadratics. As you're working with cubics in this exercise, you can of course utilise the new skills you've just done this week, things like the factor theorem and synthetic method or long division or inspection to factorise cubics, and once they're factorised you can of course use the null factor law. So I'm going to take you through a number of examples. The first example, whoops, let me just fix up that, get the size right. First example will be one where it's already factored just to show us where we're headed. So solve x minus 6, 3x plus 5 equals 0. We're utilising the null factor law, so any of those three factors could equal 0. This is a good one because that first one is just x by itself, which tells us that x is 0, and some students sometimes miss that solution. Or x minus 6 is 0, rearrange x is plus 6, or 3x plus 5 is 0, rearrange x is minus 5/3. Typically you would then put those solutions into order, minus 5/3, 0 and 6. This is an example where it was already factored. The second example might be where we're using a technique of a common factor. Solve, the example might be x cubed minus 3x squared minus 40x equals 0. There's no constant term, so we can take out an x. Now we could then use any number of techniques that you know, to solve that quadratic inside the equation there, inside the bracket there, that factor. You could use cross method. You could complete square. You could use a formula for all else fails. Just going to make that red pen smaller. So I'm going to try with the cross method. Come on. No. I'm going to try with the cross method. We need numbers that multiply to 40 but add to 3. So I'm going to choose factors that are close together in the middle of the range. 10 and 4 doesn't add to 3, but 8 and 5 certainly does. So I would use negative 8 and plus 5. Multiplies to minus 40, adds to minus 3. Therefore, x equals 0, 8 or minus 5. I'd probably put them in order. Minus 5, 0, 8. Just a little bit of revision there. You can do all sorts of techniques once you get down to the quadratic factor. Our third example is also revising work we did earlier this year. It's a grouping example. This is probably the least common. You may not use this very often at all, but you may just be asked to specifically, or you may do a little recognition when you see a problem that looks like it's got, this one looks like it's got an x and a 5 and an x and a 5. If I take that 10 out there, I'm left with a 5. I'm left with a 5 there. It looks like it might work. And the question in the text actually asks you to solve using grouping. So if I took out this x squared here, I'd be left with x minus 5. And if I took out the negative 10 here, I'd also be left with x and minus 5. I'll just check that. Minus 10 minus 5 is plus 50. Yep, I am. And now I've got this, x squared minus 10 and x minus 5 equals 0. This is another good example to do, this grouping example, because now we've got a technique of DOPS. So we're working through all the different techniques, or at least mentioning all the different techniques we've done in the past. And it's really annoying, whatever I've done there. Go away. Okay. These videos are new to us all, students, so just bear with us. This is a DOPS, so I'm going to do x squared minus root 10 squared, just to show exactly what's happening there. So I'm going to do x plus root 10, x minus root 10, using my DOPS formula, and x minus 5 equals 0. So x could be plus or minus root 10 and 5, the solutions. So that's a grouping. Less likely that you're going to have to do that, but it did revise DOPS at the same time, so that's pretty terrific. Or you might have to use the factor theorem and some division technique, which you learnt from your teacher, as we've just done in the previous exercise. For example, solve 6x cubed minus 5x squared minus 2x plus 1 equals 0. Quick look at that would say, well, there's no common factor. Can't group 6 and 5 and 2 of those numbers don't work neatly. I'm really going to have to try the factor theorem. Now, the factor theorem says that we're going to sub in numbers that are factors of the 1 or the constant. In this case, it's pretty easy. We're either going to try polynomial plus 1 or polynomial minus 1. They're the only ones we can try, because that's a 1. If that was a 6, if that constant was a 6, well, you'd try plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. You only have to find one factor and then do some other technique. So I'm going to try polynomial 1. Polynomial plus 1 equals 6 times 1 cubed minus 5 times 1 squared minus 2 times 1 plus 1. Deliberately doing it a bit carefully so you just see the technique. Obviously with 1 it would have been easy to go 6 minus 5 minus 2 plus 1 and say, oh, that's 7 minus 7, that's 0, that works. Therefore x minus 1, opposite to that sign that you've subbed in, is a factor. Once you've got one factor, you can use any technique you like that you've learned. Long division synthetic inspection. I'm going to do inspection. So I'm going to use the number plus 1 coming from my factor x minus 1. I set it up like this. We put down the coefficients of the dividend of the one we're dividing into, the 6, the minus 5, the minus 2 and the 1. They're the coefficients, and we use the algorithm, which is multiply add. I get my students to write multiply and add on the side just to remember, but that's okay. And so we don't have anything in this first box here, nothing goes there. We bring down the 6 and we multiply. 1 times 6 is 6. Then we add. Minus 5 and 6 is plus 1. Multiply. 1 times 1 is 1. And we add. Negative 1. Multiply again. 1 times negative 1 is negative 1. And we add. This tells us no remainder. These the coefficients of the quotient. The quotient will be 6x squared plus 1x minus 1. Straight from those numbers there at the end. So we have factorized. We've changed our problem from 6x cubed minus 5x squared minus 2x plus 1 equals 0 to x minus 1, 6x squared plus x minus 1 equals 0. it's become that. Of course, we need to try and factorise further. Cross method, complete the square, formula, etc. Bit of luck, it'll be cross method. We've only got a 1 at the end there, so they're going to be 1 and 1. A little bit of inspection, or you could use a cross method over at the side, or however you've learnt to do it, but it will come out to be 3x and 2x to get us to 6x squared. And I was pretty confident that that's going to be the one because it's a 1 in the middle, so I've got a 3 and a 2. That's going to give me a 1. So I need a plus in the middle there, so I'll have a plus over here to give a plus over here to give me the plus 3x and a minus here to give me the minus 2x. I'll just check that. 6x squared minus 2x plus 3x is the plus x in the middle, the minus 1 at the end. Therefore, looking at those three brackets, I've got a plus 1 from the first, I've got a plus a third from the second, I've got a minus a half from the third. Probably write the solutions like this. Minus a half, plus a third, plus 1. Don't need those pluses, doesn't matter. There are the solutions. So that was a method that involved using the factor theorem up here. Remember the factors of the 1. Using synthetic I used there to get the quotient and solving the problem. I'll give you another example that might be a little bit different. That is where you have a cubic like this. We did these in quadratics too, where you had to these in quadratics where you had to square both sides. This would be an example where you're going to cube both sides. Cube both sides. I just rearrange that a little bit. I divide 24 by 3, we get 8, and I'm going to cube both sides. Now this one has a perfect cube, even if it doesn't. If it's just it could be a surd. It could be cube root of some number. That's fine. So I'll cube both sides. X plus 1 equals cube root of 8. So the cube root of 8 is, of course, plus or minus 2. There are 2 cube roots of 8. That's not correct. It's just plus 2. What am I doing? It's not a square root. It's a cube root. Let me just get that right. Sorry, guys. If I wasn't so far in, I'd tape it again. There you go. Cubed root of 8. Cubing both sides. It's plus 2. So x, of course, equals 1. There's a solution. So that's cubing both sides. There's only 1 cube root of 8, of course. You may also, in the exercise, have to deal with sum or difference of cubes, and in the previous exercise in 6C we factorized those, and so factorizing sum or difference of cubes from the previous exercise might also be a way to solve the equations. So that's it. That's a lesson with a lot of examples that will certainly enable you to do all of 6D. The final thing would be with your CAS, of course. There's probably a question on CAS, and you should often check. Do them the long way and check with CAS. You would, of course, use solve from the algebra menu. I think it's menu algebra solve. And you're very familiar with that. I'm not going to show you how to do that. Just remember to do the comma x in the solve bracket. Comma x. And you could check with those or use that technique as well. So that wraps up 6D. You should be able to do that. I will finish it off.